Welcome to Yesterday, Today, Tomorrow. My name is Mariana Cordier, and I am your host. Today, my guests are going to share the status of the concerns of the United States infrastructure and the technology and innovations in addressing the needs of the infrastructure. My guests are Dimitrios Golias, who's the professor of civil and environmental engineering, and Nicholas Gagarin, who is the owner of Starbub Inc. So, gentlemen, thank you for being on the show. And
thank you.
Demetrius, I got a question for you. What is infrastructure? What are we talking about when we talk about concerns about infrastructure?
Thank you, Marianne. Thank you for having us. We're very happy to talk about infrastructure today. Infrastructure is pretty much everything that surrounds us. We build the infrastructure. So in other words, we build the highways, we build the bridges, the buildings, the ports, the airports. We are using public transportation systems. We are using water. We have wastewater systems for disposing of the water that we have used. It's the energy network. So it's pretty much everything. Clearly, we're talking about the physical infrastructure. The reason we have developed and we use this infrastructure is because it affects our day-to-day lives, affects our work and productivity, which means obviously economic prosperity, affects our well-being, safety. Later on, probably we'll talk a bit about resilience and sustainability are part of the infrastructure as a goal that we're trying to achieve. We're affecting the environment. Whenever we build a highway, whenever we build a residential home or a bridge, we're affecting the environment. And nowadays, we also talk about renewable energy. We are all familiar with the implications of the fossil fuel. And in terms of the impact on the environment, so we're talking about geothermal energy, solar energy, and so on.
So it sounds like there's a lot that goes into infrastructure, and that perhaps technology has made a difference in how we approach it. Would that be safe to say?
Yeah, a lot of the infrastructure was built some decades ago. And new technology, new demands from the user, us, have evolved. Of course, there is an increasing population growth. A lot of the citizens move to the large cities, and so puts further stress into the current infrastructure. And so all of these impetus creates the need to keep improving, updating, and expanding our infrastructure in all of these areas.
So that's really a big thing to work on. I mean, it's kind of the quiet giant in the room, right? Which brings me to Nicholas. Thank you for coming on the show. And your company is really exciting because you guys do a lot of work with infrastructure and the technologies required to assess the infrastructure. Do I have that right?
You're
so
correct.
Tell me about your company.
So I am a small business, and I've been in business for 30 years, looking at non-destructive testing. And I was thinking about this program, and I was thinking, how do I relate the experience that I've had? Well, it's all been about trying to understand how the needs of the community evolves. So what was needed in 1980 or 1950, when, for example, the highway system was designed, is completely different today. And plus, as Dimitrios said, the population is migrating to large cities and metropolitan areas. So what I did, I focused for 40 years of my career on understanding the condition of highways, airports, and sometimes rail, as well as waterways. And the key thing is that the more infrastructure and the resources are becoming scarcer, therefore the governments have to be smarter in how they spend their money, and they must have actionable data at the end of the day to make the right decisions to maintain the use of the infrastructure.
And how different has technology, or not so much how different, but how has technology changed the way we can use it to assess the condition of our infrastructure?
So some of the concepts are similar, but in the 90s, we could use one sensor per computer. In the 2000s, we could have a bundle of sensors to look above, on the surface, below the surface, and around the infrastructure with a single computer. And today, it's even more impressive because, as Dimitrios may discuss later, we are able to look at large database of existing information and draw lessons from past data collections as well as analysis.
So Demetrius, do we get an A or an E in our infrastructure status in the United States?
A very good question. We have the American Society of Civil Engineers, which creates every year a report card about the infrastructure overall, as well as the individual components, bridges, highways, energy, and so on. So the US infrastructure receives an overall grade between C and D, which is obviously not so good. When we go to Maryland, the overall grade is a C grade, specifically to Maryland. So if we look at the different components, roads get a C+, bridges get a B, aviation a B-, and the list goes on. So clearly there is a lot to be done. The big issue is we cannot keep up with the deterioration and the increased demand for infrastructure, which brings always to the current news the importance of the infrastructure bill that we have seen in the news recently.
Why is it, let me ask you, why is it that, there's all of a sudden this infrastructure bill that, and monies that they're looking to get to update, if you will, our infrastructure? Was this something that wasn't really being contemplated before in the budgets and the history of the roads and bridges and everything?
There has always been a conversation about infrastructure, but never a bill. So there is always this bipartisan, we're going out to politics, which is not the case. There's always been bipartisan effort, no matter what the administration was, in order to create a large enough bill to address the infrastructure needs. So in reality, we never had the sufficient funding to be able to address the deterioration and the need for expansion.
So how when we're talking about deterioration, what do you mean?
For example, we all ride on the roadways, and sometimes we face potholes and different cracks, and that may eventually create accidents. The roads could be slippery. Perhaps structurally the road is good, but the surface characteristics of the roadway create hazard conditions. And so we are talking about deterioration of the materials. We are talking about the response of a structure per se to even regular or extreme loads. Nowadays, we're talking about the impact of hazardous natural phenomena. Flooding is a hazardous effect that affects buildings, affects highways, and so on. And so materials undergo through different life cycles. And if we don't do proper maintenance, they deteriorate faster. And so we need to do the maintenance, but also we need to generate new materials that resist better to these effects. Earthquakes is another important aspect. In Maryland, we don't have much, but I remember one day sitting in my office and had an earthquake of a scale in Richter terms of 5. And so we see more and more of these hazardous natural effects. Of course, Maryland is more affected to flooding and to potentially hurricanes or storms, which affects pretty much all the different components of the infrastructure.
And in assessing it, my mind was like, do we have to rip things out, or can we, use the new technologies to assess without creating more work.
No, not necessarily. Of course, we have to assess every single component and define whether it's worth repairing it, maintaining it, or is worth replacing it. And so there are a lot of different technologies that have been developed over the years. One is obviously on new methods of condition assessment, because some of these methods sometimes are also subjective. And so we need something that is more technical oriented, objective type of methods. In terms of prediction, we also want to predict on time when do we need this type of maintenance and repairs. Then, of course, we need better materials for situations that either the loads have increased, or we expect these environmental type of effects. And nowadays also we talk about sustainability. So there is a lot of different components that have to be looked at before we define, is it time to repair it and maintain it, or perhaps replacing it?
So what is, let's talk about sustainability. How does that play into the considerations for infrastructure?
Well, everything we do affects the environment, whether it's the atmosphere, whether it's the water, whether it's natural resources, as Nicholas mentioned. As we build more and more and more, we need more resources. And so the concept of sustainability is we better sit back and reflect how we keep doing what we are doing, but change the different methods, the different materials, and so on. So for example, if I have a concrete building and I have demolished it, can I reuse this material somewhere else? And how eventually can I assess that? What are the economic implications? Clearly, anything we do has to make sense economically. So we're talking about life cycle analysis, economic analysis. And also we have to assess, okay, what is the impact on the water? What is the impact on the energy that eventually have to consume, or eventually reduction in energy? What is the impact in the ecosystem? If we have to landfill some of these materials, what does it mean? So in terms of the infrastructure, we start thinking how in the design and the development of new material can we incorporate these concepts. And as good engineers, we want actually to quantify. And so we're looking environment, we're looking cost, but also in sustainability, there is a social impact. Anything we do affects the social welfare. And so eventually that has to be part of the equation.
And Nicholas, what about materials? Are there innovative materials being developed for dealing with infrastructure?
Yes, there are, but this is not my specialty. But I can tell you that the non-destructive testing method must be material blind. In other words, we need to be able to compare composite materials, latex modified concrete, or asphalt concrete, asphalt systems objectively. So the key thing here is, yes, there are new materials, and most of those, I'm sure Dimitrios can talk more about the materials, but I was thinking about something that Dimitrios said. We think of ASCE. ASCE has become a lobbying group, and they're a motivation for having passed the new legislation. That's the first thing. But the ultimate grader is the public. And when the public has problems commuting, has problems going from point A to B, or is affected by a water main break and not getting the services they want, that is the true condition of the infrastructure. And even though it's a C, it's also very regionally variant, and different problems occur in different areas.
I know that I've seen on the news and from different areas, I don't know if it's the same case in Maryland, but where like bridges they have ceased to use certain bridges because they're no longer safe and can't hold, I guess, the weight, or I don't know what the the civil engineering technology, jargon would be, but or other roadways have been not used because of those issues. How much of that could we possibly see in the future if we don't address the infrastructure, Demetrius?
I think, well, the good news is the infrastructure bill. So eventually we'll address, hopefully, several of our needs, even though the investment that is needed is way what is being allocated. But there are a lot of examples out there of what has happened because of the improper maintenance of the infrastructure. There was, if you remember, we go back in Minnesota, there was a bridge that collapsed, several people losing their life. There was a very recent bridge in Genova, Italy, which collapsed, clearly evident of lack of proper maintenance. There was another bridge that we have actually surveyed in Sicily, which there was a fire underneath, and there was, of course, in that case, it was not an issue of lack of maintenance or anything, but the structure per se was damaged enough that is not being used anymore. And so we expect to see more and more, but there are a lot of innovation being developed that will help us eventually to optimize what we do, whether it's new materials, whether it's proper maintenance or timely maintenance or effective maintenance. And so I think we're in the right track. The infrastructure bill helps, but clearly the engineering profession understands the criticality of what we are dealing with. And so we try to optimize our resources, come with new materials, come with new design methods to address what needs to be done. Otherwise, clearly we are in a very challenging situation.
Demetrius, what do you think?
Nicholas?
I'm sorry, Nicholas. Sorry.
Yes. The answer is, for me, a bridge is designed for a certain life expectancy, given certain traffic conditions. Well, traffic has increased, and bridges have details that get fatigued faster than other details, and those are the critical aspects of a structure. So given fatigue details and a certain level of traffic when they're designed, you can see that their life is shortened if traffic increases and if the conditions get worse. So that is what the states have to deal with in terms of their structural replacement. A deck can be replaced when the supporting structure can be kept. So that's something that can be replaced every 20, 30 years to improve rideability of the structure. But a main structure cannot be replaced as easily. And that is something that's coming forward in the next 20 years, I believe. There's going to be more and more structural replacements.
And what does that look like when you're talking about structural replacement? Is that traffic will have to stop entirely for the bridge to be replaced? That
So
kind
let's
of thing?
take the example of the Bay Bridge. There are plans right now, I believe, in the state of Maryland to build a replacement bridge while the old bridge is still in service. So you don't have interruption of service, and eventually the old structure is removed.
Oh, wow. What does that look like?
Look,
Nicholas, tell me, how's that going to work?
so there's always an argument between those that want to build tunnels and those that want to build bridges. So who knows who's going to win in this case, but I think it's going to be a bridge, most likely.
And Demetrius, what does that look like when you have to remove a bridge like the Chesapeake Bay Bridge?
It takes a lot of planning. It takes a lot of logistics. What are you going to do with all of this material? How are you going to dispose it? Can this be reused? Clearly, all of these logistics will require a lot of different expertise.
Let me ask you, out of curiosity, I hate to interrupt you, but you said that some of these materials maybe can be repurposed. In what way can they be repurposed? I can't wrap my mind around that.
I can bring an unfortunate example of the Twin Towers in New York City. When there was a terrorist attack and the Twin Towers collapsed, actually the price of the metals, it went down. And the reason for that, because suddenly there was a big supply of metals that eventually had to be used. And so depending on the condition of the material from an existing infrastructure component, so we have to assess what the condition is, and then assess whether it can be reused and to what grade can be blended with new materials in order for that to happen. And so we have looked at a lot of different studies with State Highway, the Maryland State Highway and Federal Highway, on how do we recycle these materials? What are the criteria? How they can be blended, create new material, even new pavement structures because of their reuse. And this work has also is an international effort, it's a global effort. We have looked at similar ideas with some academic institutions in Italy. Now we're looking with a couple of academic institutions in Poland. All sorts of different materials, from rock dust to rubber that is from the recycling of the rubber from the automotives. We all are responsible for that. And so we have to find ways of using them, because now actually landfills don't accept rubber. And so it is a lot of research and development that goes into on assessing what are the required properties and criteria for being able to reuse these materials, with this wood from a residential building. Eventually, we have demolished that building. What is going to happen to all that materials that we have already used? And so that goes back to what I mentioned before. We are doing actually life cycle analysis. So a material, we use it for 10, 20, 30 years. Doesn't mean that doesn't have what we call a residual value, remaining value. If it can be reused, eventually we are saving on natural resources, perhaps, or energy, on water, because obviously even raw materials require water and energy to be processed to what we need them.
How difficult, taking a moment to look at the environmental perspective, how difficult is it to get materials, or are we running out of materials?
Some materials are naturally formed, like rock formation. And so we have typically to go to a quarry, use explosives, and use high energy to break down to smaller particles. We're talking about the gravel or the aggregate, depending on however it's familiar with the terms. Some other materials, like for example, cement. We use 2,700 degrees Fahrenheit to burn literally limestone, and burning relatively, we are actually generating the chemical compounds so that the cement has what we know. Once it comes into contact with water, there's a hydration process, et cetera, et cetera. So many of these processes, they are high energy and labor intense. And so clearly that's where we can save if we have an existing concrete that we can then break it down to small particles and use it as an aggregate, as an example. Gotcha.
All right, that makes a lot of sense. And Nicholas, what do you think about the impact, if you know of the infrastructure plans to repair and maybe rebuild bridges and stuff like that with the environment?
So what I can tell you is that my technology is intended to, first of all, extend the service life of existing structures. I know that the society is evolving very quickly, and therefore the modifications to our infrastructure will have to move with it. In terms of the specifics of the infrastructure bill, I don't have depth of knowledge, but what I can tell you is I see in Europe, for example, in Germany, they're reducing the number of traffic lanes in some of the highways. So they are doing away with nuclear power. There's some very significant changes. I don't know what the changes will be here, but I know that we're going towards electric cars, for example. So there will be new stations to support the public in their travels. There will be also, most likely there will be more rail and possibly more public transit, with, for example, the Purple Line in Bethesda and in Prince George's County and Montgomery County.
That's true. That's going to be exciting with the Purple Rail. And Dimitris, you've got 30 seconds. Last words on the show.
I think is the issue of addressing the infrastructure need is complex, becomes even more challenging because from one side, the population growth, especially in the urban areas, and on the other side, the fast deterioration where there is accelerated use, where there is the environment, and so on. But I think we are well prepared to address the needs of the infrastructure. And so I think the future is positive. We finally changed the way we are thinking. So we're thinking about longevity, we're thinking about sustainability, we're thinking about resilience. So it's a new way that engineers try to incorporate into rebuilding or building new infrastructure.
Well, that is exciting to know that we're on the right track, it sounds like. And I would like to thank you guys for being on the show, the audience for watching. I'm Mariana Cordier. You can catch us yesterday, today, tomorrow's show. Don't forget the show on YouTube or on Facebook. Until next time.